Hello and welcome to this episode of Stratola Spectrum. I'm your host, Dinesh Chandrasekhar, Chief Analyst and founder of Stratola. In this episode, we're going to talk about a very important topic that will resonate with a lot of you: the impact of AI on the current world of databases. Today's world has databases of all different types, sizes, and flavors. We got NoSQL databases, we got relational databases, we got vector databases, and many more. A company such as Microsoft has a comprehensive platform that allows you to choose the type of database based on your use case, the type of data you're dealing with, the deployment model, etc., etc. So, to talk to us about this very important topic, we are inviting Shireesh Thota, who is the corporate vice president of all things databases at Microsoft. With a strong background in engineering at Single Store and Motorola, Shirish now has spent close to 2 decades at Microsoft. He will bring in his unique perspective of leading all the operational databases, including SQL Server, SQL and Azure, Cosmos DB, MySQL, and Postgres. The last 3 years have been the most disruptive for the database world, where the onslaught of AI has transformed architectures dramatically across all enterprises, not just on the application side, but also, and more importantly, on the database side as well. With that said, let's welcome Shirish to the show. Welcome, Shirish.
Thank you, Dinesh. It was really exciting to be here to talk to you today. I look forward.
Absolutely. So, I know that you've been leading databases for a long, long time, and I think the last 3 years have been probably the most disruptive periods in history. So, in the last 3 years, with the rise of AI as we know it today, how has the very notion of search and querying changed in your perspective? Like, is this still primarily about faster indexes, better optimizers, and all that? Or are we seeing a more fundamental rethinking of what it means to like retrieve and reason over data?
Yeah, so I think, obviously there's been a significant amount of disruption, and that would be that would be something that's like very obvious to most of your audience. In terms of how it impacted databases, and specifically to your question about querying and retrieval and in those areas, search in particular, I do think that we've evolved from just looking at databases as though it's just a static set of information, or of course evolving set of information, and just like how AI has evolved in multiple other dimensions, we have gone from asking for exact predicate lookups to basically semantic lookups, right? So you want to have information that is semantically closer to what you are asking for. The best tool that we had in the past was like a like expression with a regular expression, regular expressions, right?
Mhm.
That's the best that you could get in beyond the exact searches. And now, if like was invented now, it would have been obviously like in my mind, it should have been vector search. It wouldn't have been a regex, right? Because that was perfect for what it is supposed to be doing in the semantic era. And so, in that vein, if you think about it, what we are trying to do now is to basically really get to the semantic search. Now, semantic search is very clear. It's super obvious to a lot of people. You are really trying to get the result based on a meaning. But the difficulty is doing it at scale and doing it with relevancy. Right? When you are thinking about how do you fetch the information for your LLMs to be able to operate it, obviously LLMs are great. They compress all the information on the internet to something that is very, very amenable for them to go interpret and predict a lot of things. But they don't have access to all the data. A lot of structured systems of records are locked in databases for very good reasons, and so they'd have to consult the databases. Now, when they do consulting into the database, most of the people begin to solve that by thinking about vector indexing, and that's a huge part of the solution. But it is more than that. You do have to get hybrid search working. You do need to get relevancy beyond vector search, because vector search, it's amazing, and I don't need to expand more for your audience, I'm pretty sure. But it has its own limitations in terms of how to get the exact, very close to what the user's intent is. This is where combining it with hybrid search is extremely important. So when you have things such as BM25, which is more, it kind of weights the search in a different way. It combines with the vector search and BM25 on top of it, and you do something called RRF, for example, reciprocal, it's sort of ranking experience. What it is doing is that along with the semantics that you want to fetch, which the nearest neighborhood indexes, ANNs, etc., very good. On top of it, you want to really get hybrid kind of search, which is like you also weigh the terms search in a better way, like how we used to do it in full text word, and then rank it so that you have an order kind of a relevancy. So that is an important evolution, and whoever does that in an effective way on the corpus of documents, that is the new game that's really have to come together. It's not just vector indexing, it's more than that. And then doing it at scale without losing the performance guarantees, etc., is extremely important. When you're trying to do these kinds of indexes in the face of heavy insertions, it's a big problem because the quality of the index, the precision recalls starts dropping, and most importantly, all these nearest neighbor indexes are very memory bound and compute bound. So do it at the scale of the disk, and to do it at a planet scale, and all the goodness of databases. How do you preserve them?
Yeah.
And that's really been the focus.
So you touched on something which I wanted to ask you. So do you see databases evolving from being systems of record into systems of reasoning, like, actively participating in inference and decision making as well, right? So if you say yes, I see you nodding. Does that shift, or what does that shift demand from a database architecture perspective?
Yeah, this is a great question, Dinesh. I do think that they will evolve. Most obviously, the way I explain operational databases is that think of them as three concentric circles. You have system of record, a system of navigation, and system of engagement. Records are basically your deepest sort of sources of truths and all that stuff. Your navigation is how you go to a portal or an e-commerce search, and you're trying to navigate across different systems. Hey, what happened to this ticket, and where did
Right.
it go, and that kind of stuff. And then engagement is the user-facing chatbots and that kind of stuff, right? And operational databases are required in all three of them. Now, when you add system of reasoning, it is in the context of all these systems. It's more of a add-on in addition to what you're doing. So a system of record may need more reasoning because you could then get better relevancy, better results for AI to operate on, for agents to go succeed, and all that stuff. Architecturally, though, I do think that you're going to start seeing more and more informations to be sort of like enhanced in addition to just the basic record. The switch, I think the philosophical switch, I think, is that it's not just about what is the record, but it is also about how did the record come to be.
Hmm.
It's the thinking and the decisions that have gone in terms of building that record. And so the databases have to evolve in terms of thinking about how do I store that, because we're very good. We've nailed the art of transactional boundaries and asset guarantees of creating the records and all that stuff. We've been doing it for 5 decades almost, and that part is very clear as to how to do it. And there's some really good vendors. Of course, Microsoft is the best in this, and and we know how to do that. But you sort of add on to the decision part of it, like how did it come to be, etc. In addition to that stuff, and I firmly believe that that is the direction where the databases have to go, because only then agents will have the power to reason the data more effectively. Otherwise, they're looking at a snapshot. The snapshot is helpful; it's very important. But they also want to know how did that snapshot come to be. You can enhance it in various ways. I would make it very efficient and keep it inside the database itself, and that's sort of like the new game.
Are you dancing around this new, hate to say new, but the most popular term in the industry today, which is context? Are
Yeah.
we trying to say,
I think they have definitely touched on the right concept there. We have been thinking about this ever since. Like if you look at what Fabric IQ does in the data platform, it's exactly that, right? So we have definitely been thinking about that in the thinking of ontology and thinking of how do we really reason and build a semantic intelligence platform. And so it's just exactly that. We are just enhancing in terms of like how do we really capture the state better, to enhance the ontologist, right? It is not like something that we want to move away from it. I believe that personally that we really get there, and this is kind of the direction that we'll go. It's very exciting. It's also at the frontier of this world. So I do think that the blogs have done a good job. They really have, like, kudos to them for sort of bringing that concept to the masses. But we've been thinking about it for a while. Yeah. Yeah.
you are referring to the context graphs
Yes,
set
yes,
of blogs?
yeah,
Okay,
yeah.
yeah,
I
yeah,
mean,
yeah.
that's one instance, but I think the best way to think about it is to really go look at Fabric IQ and how we have thought about sort of semantic intelligence
Makes
platform.
sense.
across the data platform. It's not just about databases, but databases have a bigger role to play because the records get inserted in databases. So you have to capture it at the insertion time because otherwise it's too late, right?
Yeah.
And just so that's kind of really how, connecting back to your question about system of reasoning, that is the place where we
Right.
need to anchor.
Right. One of the things that I have personally enjoyed talking to the Fabric team in various different moments in the last couple of years is how it helps like democratize access to data. I think throughout the platform, I think that's been like one way how it has made it more easier and accessible for the larger enterprise to access data and gain immediate access to like insights and everything else. So my question is kind of, you know, borderline on that, which is natural language becoming like a primary way people talk to data? And do you think we are going to rethink how databases are accessed, not just like, how they're optimized, but the bigger question is how does SQL fit into this world of copilots, agents, and conversational analytics? Because we have seen the SQL is dead blog post, like, at least
Yeah.
once every 5 years, it'll come up and you cannot kill the beast. We all know that.
Yeah.
So how does it fit into this world of copilots, agents, and conversational
So
analytics?
yeah, I mean, I think ultimately AI can't be any better than the query execution, query optimizations that we have mastered in the database spectrum, right? I think the question really is how will the application ecosystems evolve? Because underneath it, SQL is always going to be there because there's no better way to represent it in terms of getting the optimizer working, in terms of execution working. So it might be that the application is sort of translating into something else, but the relational algebra and all that stuff will remain the same way that we think about it. At least the second level part below SQL, how it compiles into getting executed and optimized, that will always remain. Because just like machine language, is machine language dead? No, it's there. In fact, it is being used more, except
Mhm.
you don't see it, right? But as far as SQL goes, I do think that I do believe that there is a secular sort of like trend towards moving into English as the interface of most of the things, and I don't think we resist it. But there is a power user and there is a citizen user,
Right.
and so in terms of the power user, what we have been doing is enable the SQL user to actually bring in the natural language inside the SQL instead of thinking it of as a, because I think the difference is, are you trying to do a one shot, I give you natural language and you give me the SQL, or you're like, I actually want to work with you, and I will do the, quote unquote macro planning and micro steering. So, you do the
Ah,
micro planning, I will do the micro steering, which is that I'm going to ask you, give me the structure of the SQL, and then I will say that over here, I actually don't want you to do all these complex joins and all that stuff, or like, I don't know how to really go invoke the right function to do the sentiment analysis or whatever. At this point, I would just say, select this data as from inner query or whatever. And then I would just, on top of it, I would say, invoke a AI function that does sentiment analysis. So I'm combining the natural language with SQL. I'm not killing SQL. SQL is very much there because I want to have the power where it is needed. And where it is complicated, I'll just invoke AI functions. Now it's on us as vendors to make sure that that relationship and that navigation is easier. So it's almost an inversion of natural language to query language, which is like almost like, bring in the natural language into SQL. Don't
right.
think of it as a one shot prompt kind of a thing. There's a place for one shot prompt. We totally support NL2QL, and I use it because it's easy, right?
Yeah.
Like I create a Fabric SQL database and I go to my Copilot and said, insert 100 records so that I could experiment with this data set. I don't need to write it. Like it just creates all the dummy data. It'll do all the basic things. And for those kinds of things, natural language to query language is great. When I'm writing something more complicated, like I'm doing some, munging of some data, and then I want to do some sentiment analysis or something like that, where I want to invoke a OpenAI function or something, then I think it's good to have the power of SQL, and then you're just plugging in the right places, right? So that's kind of really how I think about it. But this direction of like English is the new programming language, I think that there is a lot of truth to it, and we embrace it.
Good.
Yeah.
Good. Because my subsequent question was this shift between the roles of the developer and the data engineer, right? So do you see that change? And then we also are noticing that things like schema design, semantic modeling are becoming a lot more important than actually writing queries because, as you said, it's handled underneath.
Yeah,
And do you feel like that's kind of like the
for
world
sure.
that we're moving towards?
I definitely think, and it is, I think the progression is still mid-flight, and I really don't know how, like, the best analogy that I can give you is that everybody is a full stack engineer now. One of the things that people struggle with is the tooling that's needed to go build a React app, for example. You don't need to do all that stuff now because agents will do that for you. The copilots will do it. GitHub Copilot does an amazing job at it. And then you really go into most of the engineers that I work with, and personally myself, we're good at the systems stuff, uh, or we want to build the like actual core application logic. The intermediate tooling that's needed, the framework that's needed to go build, the right package.json, the right, React app, the right Tailwind stuff, and all these things. All that is very important. It's an extremely important skill. If you're not good at it, no problem. The new engineer is a full stack engineer always, right? In that sense, the data engineer and the developer aspects, I think, are also going to get like sort of, collapsed in various ways. And the specialization will still always remain. Just like there's
Yeah.
a need for a systems engineer always, there's a need for like a great UI engineer always. The specialization will always remain, but like I think volume wise, there's going to be much more sort of crossplay here.
Nice. So shifting gears a little bit, one of the things that got me excited in the last few days is this article from Sam Altman about scaling Postgres to like power 800 million ChatGPT users,
Yes,
right?
yes,
So this was an
yes, yes,
OpenAI blog post, and
yes,
it was pretty interesting to read the whole thing.
yeah.
And I saw how they were leveraging Postgres and Cosmos DB, in parallel to kind of address this kind of scale that they were trying to get to.
Yeah.
So my question is, what is OpenAI's decision to push Postgres to millions of queries per second? Tell us about the maturity of relational databases in the first place, and then what does it also signal about the future role for traditional SQL systems in AI-driven workloads?
So the architecture that they were talking about basically involves a couple of things. There are two databases, in fact, that they use. They use both Postgres and Cosmos DB.
Yeah.
They use Postgres for authenticating the users and trying to do sort of like rationalizing their billing experiences and that kind of stuff. And then they use Cosmos DB for messages and any user-facing kind of application. So, again, going back to system of record versus system of engagement. The system of engagement, the top concentric circle is Cosmos DB, where they're really trying to get high volume of data and scale it massively, both on reads and writes and all that kind of stuff. System of record happens to be Postgres. And in this case, it's Azure Postgres. So we have an Azure Postgres Flex version, and that's basically our managed instance experience of vanilla open source version. And that's been their backbone for, and the blog basically is focused on the Postgres. You would see how they have really used Postgres in a way that caters to the advantages and the challenges of Postgres. Like I always believe that every database has different kinds of decision optimization points, and certainly Postgres has some of its own optimization design points, right? It is great for general purpose workloads. If you are inserting a lot of writes, then because of the way that MVCC works in Postgres, you get a little bit of like garbage that needs to be cleaned up, and you need to do some work there in terms of managing it. And so they've realized that part, and they basically said, you know what, we're going to use a single writer and scale it for reads. And if something needs like massively more writes, then we'll go to a sharded system like Cosmos DB. That's kind of, a very pragmatic approach that they've taken. And I believe that, I think a combination of relational, non-relational systems is the best way to go, because you get the best of ACID, most functionally rich query kind of capabilities in a relational database. If you want to scale massively, and if you want to really go to high availability to 5 nines and that kind of stuff, then non-relationals, in this case Cosmos DB, is a great bet. Speaking primarily to your question of future of relational databases, I do think that Postgres is just incredibly diverse, given the extensibility mechanisms that it has, and given how well it's being received in the community. It truly has sort of like
Second coming of Postgres.
yeah, in the last few years, yes,
Yeah.
right. And we embrace it fully, right? Like I think one of the things that Postgres, vanilla Postgres, the open source version, doesn't do that well is that it's not cloud native, right? It is not designed
Mm.
for. It is designed again for a traditional relational scale up, in a single box kind of a
Yeah.
thing. Replication is very old school, and scaling is it has its limitations, etc. So, but it is great for what it is supposed to be, and we have done lots of innovations. We will put out some technical blogs that explain how if we had to do some work to scale Postgres for OpenAI kind of scale. In this case, for instance, we had to do something called cascading replication. The replication, there's a limit to how far Postgres can go well. So we had to build like, add one secondary and don't replicate from, if you want like, let's say, tens of secondary replicas so that you can scale reads.
These guys use like 50 read replicas or
Correct.
something.
They had 50, right?
Yeah.
And so one approach is that primary keeps replicating to all 50. That's just going to take down so much of capacity of primary that your writes will get impacted because your writes have to go to primary. Instead of that, you cascade the replication from the secondary. So your primary will replicate to a secondary will
Ah,
replicate to the next one or next four or whatever, and then you could do that kind of stuff. So that's an innovation that we had to go build, and we'll write more details and put it out there. But at the end of the day, there's a cloud native challenge, recognizing that we basically are building Azure Horizon DB, which is the next version, as to like bring in all these learnings and make it cloud native so that you can scale massively on the storage. You're not dependent on your local disk. You're basically now decoupling the storage and compute, so your compute can grow independently of your storage. Storage can grow massively, hundreds of terabytes, 200. You can go really large. Your read replicas can be large because your log is shared now. Instead of having one node as a primary and then you are doing sort of RPC between machines, the
hmm.
architecture is very different. You're sharing the data effectively across all these things. You'll also get the benefits of faster failovers, better commit latency because you're just writing log and the data pages are asynchronously created. So a lot of cloud native stuff that's going to get plugged in. And so that is the birth of Horizon DB, in addition to what we have is Flex. And we have definitely both are important. But to kind of, tie it back to your question, I think Postgres is it's just a phenomenal database. It's a great relational database, but relational databases are one of those things which will always be there and will always be super important. We're very proud to sponsor many of those things. In fact, SQL, Azure SQL Server, and Azure SQL are our databases. Have we been building it for decades? Very battle tested, absolutely performant. But we embrace Postgres as well if somebody wants open source. On the other hand, again, as I said, an OpenAI case reflects this really well. You do
Hmm.
need a relational database and non-relational databases in certain cases, not all cases, but in certain cases, many cases, in fact. OpenAI ChatGPT is a great example. And we're thrilled that they use both of our flagship databases, both Azure Postgres and Azure Cosmos.
Nice, very nice. Congratulations on the success story there. It's nice to see it coming from a huge, massive public implementation like this, and that kind of speaks volumes of the scale that you can achieve. But from Microsoft's own vantage point, and given that you just said, like, you have like a couple of these flagship products, plus your main key product, which is, again, SQL Server and like few other databases that you own. How do you think about like unifying transactional, analytical, and AI workloads without fragmenting the data stack even further? Like, is that going to be the future? Like, with like everyone having like a special purpose database for like special needs, or do we even like have a future where everything comes together at some point?
So I definitely think everything has to come together. And I think, there is and it needs to be done carefully because oversimplification, it can be dangerous. When
Correct.
you really want a purpose built like a custom purpose, like a highly optimized kind of a database for a specific scenario, you have to go use it. Like graphs are a great example. If you try and do everything with a general purpose relational database, it has its design points. It's not like it's a bad product. It's a fantastic product. But you got to use the right tool, right? But at the end of the day, you do need to think beyond what the operational databases are sort of like. Yes, the data is generally born in operational databases, but you want to shorten the time it takes to reason on that data and gather insights and really have feedback loops with the analytical side of the world as well. And that's been like a very important problem for a long time. People have done all kinds of things because you want to really build all kinds of streams of operational databases, curate them, and then put it into a warehouse, and then do custom sort of like
Right.
cubes and that kind of stuff. And it has worked well, but it's costly, and it is error prone, and too many systems to stitch and all that stuff. And this is the reason why we are going to bet on Fabric as the story for our data. And databases will and are already part of Fabric, and we're going to continue to invest in that space. So Horizon DB will also come into Fabric, and when we bring into Fabric all these databases, we will continue to evolve it. It's not just about, obviously it starts with making sure that the data from operational data goes into one lake, and it gets sort of like, you could now do, some of my favorite examples are people trying to cross join between Cosmos and SQL, and
Mm.
Postgres data with Cosmos data, whatever. Because again, as I said, a lot of applications require system of record and system of engagement, and you want to look cross join these kinds of things. It's easy now because you put all that stuff into one lake and you do a 3-point join between, they're all lakehouse tables at some point, one lake tables, and you just join them across. And so you could do all that things. And then on top of it, you want to gather like deep insights. You don't have that kind of a computational engine on operational databases like you have it. Finally, I think the most important thing is AI. If you want your AI to succeed, it's obviously very, very clear that you'd have to have the data in one place, in one shape, and it's a very well understood kind of shape. And this is where I go back to the the whole context graphs or ontologies or IQ and that kind of stuff. It's extremely important that you need to have reasoning, you need to have sort of relationships, permitted actions, policies, and all that stuff on the entire state of the data. You can't leave out operational stuff out or streaming out and then do them. Or if you try and stitch them in multiple places, it's going to be hard. So while to summarize, while you will need these custom tools for custom problems, you do need all of these things to really merge into one place where you have a unified data platform, unified data estate.
Right.
And we're going to just exploit these sort of like benefits. There's a lot of emergent properties because of this intermingle. Things such as like, hey, we can enhance the records with a lot of history that is coming from databases. We could gather the insights much faster and reverse ETL perhaps. You ETL'd it out, you did a lot of cooking, and then you reverse ETL some portion of it so that you can serve it for an operational application. Now that the data app and the data developer, the data engineer, and the app developer, they are also converging. You don't want to have two different places where like, you don't want the Python developer, the data science developer saying that I built a great, notebook, but I don't know how to operationalize it because I don't
Mhm.
have like a database that I want to serve it from. All that stuff is taken care in Fabric. In fact, we're going to build a great application platform experience as well to make it happen.
Fantastic. Well, on that same line, touching on, since we spoke about AI as kind of like one of the areas as well, what we all have seen is like, when people claim like 2025 was the year of agents, I don't technically think it was like, it was more like still experimental and prototyping all around. But I think 2026 will definitely get more serious, because there is not only adoption that is going to be almost like pushed into happening because CIOs and CTOs and CDOs, everybody needs to see ROI. So they're going to start pushing agents into production and seeing, let's see what happens, right? So they're going to like take that plunge. So 2026 is probably going to be the real year of the AI agents. But on the development side as well, what I notice is that all the companies that are building agents, they are addressing and tackling problems that are bigger and more forward thinking, like having agents having like long-term memory, episodic recalls and context persistence and all those kinds of things. So is that a problem space that your team is actively thinking about? And how do you see databases becoming maybe like a memory substrate for AI agents?
Yeah, so as you can imagine, they can definitely play a big role here. I broadly think of this whole memory thing into sort of like, again, the literature, the popular literature out there, into four different types, right? You have a working memory, which is basically the current current context, right? You're trying to do in prompt and you want to have like just a recall of what is happening. It's ephemeral though, right? It's not something that you have to
Correct.
store in. But it is a working memory. It's an extremely important part of it. In fact, it's probably the most used. Now then there is a short-term memory, which is a recent interactions. Maybe I was like sort of I kicked off I kicked off a prompt, and then I came back, and then I want to understand, like, hey, yeah, I asked you something to do, go do a research mode. I want to extend that and add more to sort of like, enhance my interaction, a recent interaction. There, you do need some store, but it is more like cache kind of a thing and like a key value kind of a store, etc., which we absolutely play a part. Cosmos DB is designed for this, and we have our own cache stories and that kind of stuff in all databases. So we definitely do a good job there. Then you get into, after working in short term, you get into long term, and then I think
Mhm.
there's long term two things. There's a semantic and there's episodic, right? So in the long term, if you think about semantic memory, then you'd have things such as like, hey, I got some kind of facts, I got preferences and all this stuff, and you would use people saying that, oh, you need a vector database for it because you're trying to get semantics, and I think I think it's right. And here again, our philosophy has been that every operational database is a vector database, because we just have to consolidate vector indexing as though it's another feature of a vector database, instead of thinking of it as like you need a new database for it. We don't do that, right? We don't have to go and build I got a new index, I don't build a build a new database, right?
Yeah.
We did this with XML, we did it with spatial, we did it with full text, we did it with JSON. It's not like we kept on building new databases for spatial, new databases for XML, new database for spatial in the past. JSON is special. Obviously JSON is also part of relational databases. Postgres has a great JSON indexing. Our SQL database is great SQL JSON indexing. But anyway, in any event, I think the point is every database is a vector database. So we have great vector indexing powered by something called DiskKNN, which is our flagship nearest neighbor approximate nearest neighbor algorithm, and that base family of algorithms. In fact, it is now part of all the databases, Cosmos, Postgres, MySQL, and all that stuff. So that's the long-term semantic memory. You want to retrieve facts, preferences, and that kind of stuff in a very quick way. And
Yeah.
then as you said, episodic memories, right? This is really where you're trying to get decisions, outcomes, traces, logs, and that kind of stuff. And this is where people generally sort of like talk about graph databases, but relational databases do a really good job there, right? And so a lot of the early sort of like agent demos, etc., they would say that, hey, we store memory in a vector database. That's very partial truth, because I do think that when you think about it that way, it's like saying we store company's history in a search index.
Mhm.
It's true, but it's dangerous if you think of it like literally that way. The reason is because they're not great at versioning. They don't understand causality of sort of like events. They don't have constraints, no governance, and that kind of stuff, right? If you want all of that stuff, then you certainly need a proper database. And there's a place for vector indexing, there's a place for cache, there's a place for databases. We are absolutely in this game across the board. So if you go to Foundry, we basically offer operational databases as the sort of memory layer for you. Wherever you're trying to build an agent, if you want a memory layer, we have a service that basically offers it. And if you think about the popular frameworks like MemZero, etc., we definitely integrate into those kinds of frameworks. So yeah, the reasoning calls into the memory framework calls into the database. We're going to be there as part of it. We're making it easier through Foundry for semantic recalls, episodic memories, relationships, etc., through vector databases, caches, non-relational and relational database. So it's a
Fantastic.
very exciting phase, and very thrilled to be part of this.
Yeah. No,
Yeah.
really exciting time for sure.
Yes.
So a slightly related, curious question. It's
Yeah.
a fun way to think about. Do you think like whether AI agents will live closer to the data, like meaning inside the data platform itself, rather than calling external services into it, right?
Yeah.
So, what does that mean for database design in that
Yeah,
case?
no, this is like, this brings back the memories of business logic. Where does it live? Is it like outside of the data, or is it store procs inside, or is it like mid-tier logic and you pull the data kind of a thing? I think it's a similar kind of debate in a different way. And I think the answer is both. I don't think it is like either or. There will be scenarios where you don't want to exfiltrate any amount of information anywhere because of security reasons, and you want the agentic loops to be part of the system. You see that definitely inside the database where they're trying to gather, they want to call the AI model outside, or in some cases they actually just want to host it internally.
Yeah.
Like if you're, our SQL Server customers can host it locally, and they can definitely call into a gateway to go do that. And even some of our offerings, we can create like an isolated sandbox where you can run in the cloud. And in some cases, like in fact in Postgres, we actually did this local embeddings model. We ship the model with you. And there are like many small but custom built kind of models where you just locally do it. You don't want to exfiltrate anything. You don't want to take any risk of moving this data outside if you are like regulated, confidential data and all that stuff. But you want your orchestrated agentic orchestration to be able to delegate something to the database agent, perhaps, which is which is
Hmm.
inside the database. It does its thing and it gives a result and go back. And then so that is sort of one way to do it. But the most popular way, I do think, and which is already happening, is that there are agentic flows that are just consulting databases through MCP endpoints, and they are getting a very relevant information, not all of the information, appropriately to pull it and then go do this, be it rack patterns, be it hybrid or just interact with the database through MCP. And I do think that that's happening a lot now, right? Almost all the agents, apps, etc., go consult an MCP endpoint of the database. That's happening a lot. Pushing the agentic flows inside the database will also happen for sure, for the
Yeah.
same kind of reasons, where it's efficiency and so how closer you get it into the query, closer to the query execution, it's to be seen. But I think these use cases are evolving.
Right, right.
Yeah.
And I think you touched on a couple of things about like security governance as well as like pushing agentic flows closer and all that. So, which begs the question that as AI agents become more autonomous and gain direct access to enterprise data, how do we rethink, security and governance, right?
Yeah.
So the traditional RBAC model, does it still scale in an agentic world, or do we obviously, I think we need context-aware, intent-driven kind of access controls, but how do we implement that in the database designs that we have today is the question.
That's a really good question. It's probably one of the most important questions that we should be asking and thinking more across the industry. I think this notion of really designing database schemas or security perimeters, etc., need to evolve to account for agents as just another entity that's going to access.
Yep.
And it needs to account for the behaviors of agents, which are very different from the human behaviors, primarily because they don't get tired. They don't have their feedback loop, and the processing, that cycle is so compressed that it can keep attacking you in a much
Yeah.
faster way, or keep requesting even for a general reasons. And the whole RBAC mechanism of how do you delegate it into sub agents and who can go on to do many things, and are you really cascading the RBAC properly, or do you need to do something else? And does RBAC need to be defined in a way that this RBAC is applied to these agents, but it has components or sub-components that it can give to sub-agents? And
Yeah.
so you're not just passing the token as is, but you're passing a portion of the token. So does it mean that we need to come up with a different kind of hierarchical RBAC that basically goes through these agents, and you just have like really scoped kind of tokens and that kind of stuff, and just generally the revocation challenges? How do you really define the permit deny models, etc., for agents? Those will have to be a lot of it should be similar to what we have already done with the humans, but I think a lot of it will need to be evolving to definitely take into account the just the agentic behavior, right? Which is going to be very different. and and
Very different.
and then there's a totally different aspect of it, which is how adversarial they can be if they want to be, and how do you protect yourself, right? If
Right.
somebody, it's like we used to do fuzz testing to try different kinds of attacks and that kind of stuff. One of them, we do a lot of pen testing, penetration testing, and all that stuff in the security space. But
Right.
those look like primitive, extremely primitive in the face of what a high-end model could go and discover and attack and all that stuff. And so how do you really protect? That's a very big question. And the only way to protect those kinds of things is to actually, you have to attack it with attack and defend with an LLM model, not with the humans, right?
Right.
That'll be completely mismatched if you are trying to reason in a rules-based world with a rules-based world, in a world that is so fast and so high compute intensive, intelligent kind of an environment. So, if offense is that way, the defense also has to be in that way.
Mhm.
And evolving into that LLM-based security defense, etc., is certainly a new area. Very important for databases more than anything else.
Are you clear on where the future trust boundary should sit? Is it at the model layer? Is it at the data layer, or somewhere in between? And how does Microsoft think about enforcing that boundary?
So, I think it's hard for me to give a broader answer for Microsoft. I definitely there's better experts at
Sure.
it in the company. But when I think about it from a database point of view, I do think that we'll have to build on each other, right? Because it's going to be hard for me to go and account for and just compensate for or think of it as like offsetting for model, because it's just ton of work that goes into it. And so we need to, and this is one of the strengths of Microsoft, right? We have the entire stack, and we can sort of build on each other's strengths instead of thinking of it as like, oh, but that was not my problem, go talk to this other vendor, right? That is not how we do it. We build a full stack, comprehensive stack, and we can build on each other's thinking, and we have basically a very structured way of thinking about what's roles and responsibilities of each layer. I certainly would do everything we can at the database layer in terms of protecting, how do you access the data, what is it doing to integrity constraints that you have set in place, whatever is your identity isolation, network isolation policies, and all that stuff, as far as the service goes, as well as the engine goes. Now, I do have to trust my friends, and this is kind of the strength of Microsoft,
Yeah.
where we have if you look at Microsoft's policies, for example, we have a comprehensive responsible AI policy that goes across the board, not just the usage, but the training of models, building of it, and how do you really invoke it, and how do you protect customers, and we just build on that framework. So that sort of is the best way to go.
Yeah. No, I don't think there is a very clear
Yeah,
open and shut, answer for something like
there
this.
is.
There are
It's
too many
evolving.
parameters and too many controls and dials that need to be moved to arrive at a solution. So
Absolutely.
I understand.
Yes.
All right, enough of all the tough questions. So I'll move to something easier. So, which is, uh, if you look at all the AI-driven changes happening in the database world today, what are you personally very excited about solving right now, and why?
I think this whole when you think about how you started your career, let's say, maybe a couple of decades ago, whatever, the way we used
I'm
to,
more than that, as you can tell from my hair, but yeah,
I mean,
sure.
I used a couple of decades to combine both of us. But I think it's sort of like the biggest thing that I can tell you is just the excitement of the pace. It's a meta point, but it is the excitement of pace, because everything was like you learn a technology and you wait for, wow, what is this gonna do in the next version? And you wait for a couple of years for the next version, and then you're like, whatever application paradigms, whatever security whatever you did, and then completely becomes, oh, you didn't have to do all that stuff, but it would take a couple of years, and before you sort of have to
Right.
reorient yourself, and even just waiting for the next version of like .NET or whatever, right? It was like, oh wow, I used to code like this. Now I don't need to. I have this lambdas and
Exactly.
all this stuff, and like I can go and like reorient myself and that kind of stuff. It's not the same example, but you'd similar kind of trend there. Now you get to do that every week, and you basically are like, oh, I was doing this. Now you should be using skills for this. That's like, you shouldn't be doing it this way. This is a sub-agent problem. You're thinking about it in a very different way. And then you sort of like, okay, all right, let's reorient ourselves and go and go off and do all that stuff. The pace at which it's growing right now is probably the most exciting thing. Honestly, the once you get hooked to building applications through the agentic sort of tooling like GitHub CLI, sort of like in the recent times that we've been playing with in our company, it's incredible productivity, and it's just so exciting. So
Yeah.
I'm super excited about that stuff. Personally, I'm also very eager to see what happens when AI escapes into not escapes, evolves into physical world. Like we have been like, I think it's the coding is the center of it, and it is a perfect use case. And then we've talked about productivity and like sort of knowledge work and that kind of stuff. And then there's a personal work and that kind of stuff, but it's still digital.
Right.
Then what happens when it sort of like evolves into the physical world? I'm so, and I think I experience it in some ways when I'm driving my my cars in the morning
Yeah.
or whatever. And a lot of us are already experiencing portions of it, but you can see that when cars are autonomously driving themselves and you sense that, oh wow, this is neural network doing all this magic, you're feeling it. But if it starts touching more and more parts of your physical life, daily life, yeah, the world is going to be different. I'm very excited about
No, I hear you. Almost like a build-in public declaration kind of a thing.
it.
For
Yeah.
2026, I'm like thinking that I'll invest some time into building some physical AI work.
Nice, nice.
Yeah, no, I've been like dabbling with all this, code gen tools, and it's like fascinating. The
Yeah,
world
yeah,
suddenly has like opened up like crazy. And
yeah,
the nerd that I am, and I just wanted to like, at least try out a few things. And so I've asked my high school, son,
yeah,
to build out, like he's into robotics and stuff.
yeah.
So he's going to build me a robot, and then I'm going to like, start programming that and, feed some LLM based instructions into it. Let's see, how that shapes up,
I'm sure that'll
project
be
for the
exciting.
year.
Sure, that'll be exciting. And there'll be a day where there'll be more robots than humans, right?
Yeah, of course, of course. All right. Last question. In a way of wrapping up, if we fast forward like 5 years, what would you like people to say that Microsoft got right about the convergence of AI and database?
Oh, that's a great question. We certainly want to make sure that we don't forget about the core needs of databases, right? In this whole rush of things and the kind of excitement that we have, we never want to go lose the focus on resiliency and security. And we
Mm,
want our customers to remember that they can come to Azure, they can come and trust on Microsoft to basically get their business going, and they can really empower themselves to go do bigger things. You do not want to do shiny things and then just have a whole lot of vacuum underneath it, right? It's easier to do shiny things, especially easier in this world, in today's world than a few years ago, whatever. But I want to make sure that we will always be remembered, and that's been our center of focus. That's the mission that we always are in, uh, again, to empower them to go achieve bigger things. It starts with foundation fundamentals things, resiliency and security, etc. This is a constant. We always strive to go do that. So that's definitely the most important thing. That beyond that, I really do think that databases are some things that will never be replaced, because you certainly mostly because I feel like, what would AI replace it with? Unless you have all the compute in the world for free, you would be doing the same thing with an extremely ineffective way, if you don't have a database, right? The success for us is to make sure that we evolve it in a way that you basically have your application be the star of the game, and just almost forget about database. Even though I run databases, I am very happy to basically take a side character role or whatever. You don't need to think about me, because I'm running autonomously and I'm doing everything that is needed for your application.
mm,
The way you build about it, the way you think about databases, etc., needs to. And look, a lot of my DBA friends would be like, hey, that's just not going to happen. And I don't believe that this is something that you should think of it as a either or kind of a stuff. We are empowering them to do more and more and more things. And that's kind of the world where we want to be, where it is super simple, it's optimized for AI, it's autonomous to the degree that humans are in the loop, but you're thinking more and more about applications. When you, in
right.
the beginning of the 20th century, anybody who purchased a car need to understand what's under the hood. In the beginning of the 21st century, I at least don't know what is under under the hood, right? I have zero understanding of the
Yeah.
engine of the car, right?
The reality is there is nothing under the hood. If you open up the Tesla, front,
Yeah, there is
there's
that.
nothing.
There is that, right? Somebody in the future would say, like, what does it even mean? What's under the hood? There's nothing, right? Why does even English have this idiom, whatever phrase?
Yeah.
But I think that's sort of like that century will be compressed into years, months, or whatever.
Yeah.
And in 5 years, I do think that 5 years is too long of a time for that
Yeah, I know.
not happen. If it didn't happen, then I think we failed, right? This is again. to empower the existing people to do more and more things. They're already using it, right? They're already thinking of it in a maybe we are like 20% of the way there. I always tell people, whoever is super skeptical of this, is to look at the slope, not at the intercept, right?
Yes.
So just think of the rate at which we're growing. Your answers are in that, right? If that slope starts saturating and going in a different way, then we will have a different discussion. We should be open to that, right? There
Yeah.
may be a breaking point, but currently the trend is looking incredibly positive.
Very cool.
Yeah.
Very cool. No, I appreciate that.
Yes.
Thank you so much for the insights. I love the clarity in your responses and how you're thinking about the convergence of AI in databases today. And there is a lot happening, as you and I both agree, that is very exciting times to be in. And it was such a wonderful time, chatting with you about all of this.
Likewise, Dinesh. Thank you so very much. It's really an honor and a pleasure to have the opportunity to be on your podcast, and I love chatting with you. Thank you.
Awesome. Thank you.